So here, I need to know how to deal with x over 2. It's relatively straightforward, except for the domain. Okay. So this is linear, so I solve it just like a linear equation. First off, it's going to give me sine of x over 2 equals 1/2. Well, I'm given that the interval where x is 0 to 2 pi. But what I'm going to do sine inverse of is this expression, sine inverse of x over 2. So this means I'm only dealing with half the interval. Okay. So I'm looking for angles between 0 and pi radians, not 0 and 2 pi. Okay. So I want to know what angles in this interval spit out 1/2 when I do sine to them. Well, that's pi over 6 and 5 pi over 6. Both of those are less than pi. Okay. Now, I got to finish solving this equation. I'm going to multiply both sides by 2. That's going to give me x equals 2 pi over 6, or pi over 3, and 2 times 5 pi over 6, or 5 pi over 3. Now, this is in this interval, but this one's not. Is that still an answer? Yes, because x is this interval. X over 2 is in this interval. Okay. So if I want all this, that's if I want solutions in a certain interval. If I want all the solutions, then I think, okay, x over 2 is the same thing as 1/2 x. Well, if you remember from when we graphed trig functions, 1/2 x, the period is dependent upon this number. This number represents how many waves in a normal period. Well, that's half a wave in a normal period. So the period of this function is 2 pi over b, or 2 pi over 1/2, which is 4 pi. And this is how often the graph repeats. Okay. Well, if it repeats every 4 pi, then I'm going to take these two basic answers over here and add multiples of 4 pi. So that's going to be pi over 3 plus 4 pi n, and 5 pi over 3 plus 4 pi n. So this is all solutions, and this is solutions on a particular interval.